Today we'll be covering the nomenclature of the following 5 different functional groups, which are all listed under carboxylic acid derivatives. You'll first find the parent chain, which is the longest chain that includes the carbonyl group. You'll number the parent chain beginning at the carbonyl carbon, so it's very much like an aldehyde. So you don't have to think too hard about these. You're going to use the name of the parent carboxylic acid. We're going to drop ic acid, and we're going to add the ending YL, followed by the name of the halogen. It's kind of odd, so the parent will actually end, if you drop ic acid and add YL, it's going to end in OYL, OEL, a little bit strange. And between that and the halogen, there will be 2 words in its name. Okay, on this first molecule, let's first find the parent. It's a pretty obvious one. It'll be right there. And so we are looking at a total of 1, 2, 3, 4, 5, 6 carbons. And let's just go ahead and number them. 3, 4, 5, 6. Okay. So this one's pretty straightforward. It's just going to be 4,5-dimethyl. And now it would be hexanoic acid. So let's go ahead. Hexanoic acid. We're going to drop that ic acid part and put a YL, and then in a separate word we'll put chloride. And remember, there is a space between the hexanoyl and the chloride. Now on the next one, let's go ahead and identify the parent again, and that parent will contain the carbonyl of the acid halide. It's an acid bromide in this case, so right there to there to there, and then there. That other carbonyl is in the chain as well. It's an aldehyde though. The winner in the priority race is the acid halide, and so we're not going to be worried about the aldehyde. It's actually going to be a substituent. So again, numbering the carbons, we have 1, 2, 3, 4, 5. Now I don't want to call the aldehyde a formal group, because if I call it a formal group, what I in essence have done is I have taken and cut the chain right there. And I don't want to do that because instead of having 4 carbons, it can be longer, it can have 5. So I'm not going to be cutting that chain right there. What I am going to do, and let me erase that so we don't have to sit there and stare at it. What I am going to be doing is I'm going to be including that carbonyl as something on the main chain, and it's going to be an oxo substituent. And so I'm going to have 5-oxo, and that's my only substituent, so that's pretty straightforward. And then there are 5 carbons in the chain, so it's pent. Now normally I'd do pentanoic acid, but there's an alkene actually in the parent, so it's a pentenoic acid, and that double bond is at 3. So we'll do pent 3. I'm going to put the E right with the 3, so it's trans. So pent 3E, then ene, it would be enoic acid. I'm going to drop the ic acid, put a YL, and then bromide. So it's again 5-oxo-pent 3E enoyl bromide. Sounds a little bit weird. To name the anhydrides, we're going to follow a similar set of rules. We will again number the carbon chain, and we want to include the carbonyl carbon. We are going to pick half of it though, and so as an example on our bottom molecule down here, when we number the carbon chain, we're going to be looking at it just on that half. This is of course assuming that your anhydride is symmetrical. We're not going to name ones that are asymmetrical. It's a much more complicated nomenclature. So you'll be doing ones where the two sides are the same. So we're just going to name one side, and then when you indicate that it's an anhydride, it will let everyone know that the other side's just the same. So you pick one side of it and number the carbons in there. So this one, for example, would be 1, 2, 3, 4. It's 4 carbons long, as is the other side. We'll be using the oic suffix. So we're going to keep the ending of the carboxylic acid. So here 4 carbons would be butanoic. We're going to keep the whole oic part, and we're going to add to the end of that the word anhydride. And it will be 2 words. So we're going to put a space there. And then, of course, substituents, they just go on like usual. So this one right here has a methyl at 3, so it will be 3-methyl. And it is butane, it's 4 carbons, so butane. So we'll go butanoic. Came from butanoic acid, it's no longer carboxylic acid. It is an anhydride. And that would be 2 words. So there's a space after butanoic. Okay, going to the next one. We see both sides are the same, so we'll just pick one side. I'll start my numbering at the carbonyl carbon. So there's 1, 2, 3, 4, 5. I don't want to go into that cyclopentane. It's actually a substituent. Okay, so let's go ahead. We have a bromo at 4. So this is 4-bromo. And then we have our cyclopentane at number 5. So we're going to go 5-cyclopentyl. There's a methyl at 3. And we'll have a 3-methyl. And that's it for substituents. Now it's 5 carbons, so it's based on pentanoic acid. And so we're going to put on the pentanoic. It would be attached to methyl, but I'm out of room, so we're going to just move over there. So it's pentanoic, a space, and the word anhydride. For the nomenclature of esters, it's also going to be a 2-word name. The first word is going to be the alkyl group, the R group, that is attached to the oxygen. So when you're looking at an ester, we have our carbonyl, we have our oxygen, and we have our R group. This first one is going to be the name of that alkyl group. Then we're going to go ahead and kind of name the actual parent part. We'll determine, as usual, the number of carbons in the longest chain containing the, wait for it, carbonyl group. We'll begin the numbering at the carbonyl carbon. And as far as the parent goes, we're going to name it as a carboxylic acid, just like we had done before. We're going to drop ic acid, so the ic acid part goes away, and we're going to add the ending ate, A-T-E. So the ending of an ester, since it's a carboxylic acid, it's say butanoic, we're dropping the ic, so there's still going to be that O ending, and it's going to be ate. So it's an O8, pentanoate, butanoate, something like that. And then, as usual, number substituents and put them in. Okay, let's go ahead and do this first example. Going to the first word, it will be the alkyl group attached to the oxygen, that one right there. And so our first word will be ethyl. Then a space. Then we have to name the rest of this. So going through numbering 1, 2, 3, 4 carbons long, and there's a methyl at number 3. So we'll have 3-methyl, and then it's based on butanoic acid, So butan O, we're going to drop the ic acid part, and we're going to put a TE. So it's 3-ethyl, 3-methyl butanoate. All right, now the next one. That's a scary looking one, but let's be consistent with what we're doing. We will start out focused on that group right there. It's a propyl. That's not too scary. So this can be a long name, so I'm going to squeeze it way over here. So we have propyl, then a space. Then let's go ahead and start numbering the parent. 2, 3, 4. Okay, so I'm seeing 9 carbons in there. I have 2 methyls and ethoxy, and then a double bond in it. Okay, so methyl, ethoxy, ethoxy comes first, and it's at number 7. So we'll put a space after propyl, and we'll go 7-ethoxy. Whoops, I don't want ethoxyl, I want ethoxy. And then we will have our methyls, so 5,6-dimethyl. Then it's going to be based on known enoic acid, but since there's a double bond, it's going to be known enoic acid is going to be kind of our base parent. And so we will put known. It's nonene, so I have to say where the double bond is. It's at number 5, and it's an E. 5E, ene. The ending would be oic acid at this point, but we're going to drop the ic acid, so we will put as the ending O, and then, since it's an ester, we replace ic acid with 8. So it's propyl, 7-ethoxy, 5,6-dimethyl, known 5-enoate. We're going to treat amides in 2 groups. First we'll do primary amides, which are where the amide, the amine part of it, is just an NH2. And then on a separate slide we'll talk about what to do if there are alkyl groups on that nitrogen, so if it's substituted. So we're going to do our standard thing that we've done. We'll start at the carbonyl, and we'll find the longest chain, and we're going to name it as a base of a carboxylic acid. We're going to drop now the whole oic acid. Even the O is going to go in this case, so we're going to drop that whole thing. So basically it's the number of carbons is all we're going to be indicating, and then we'll be adding the word at the end, amide. So as an example, say that it was butanoic acid. What we would do is we're going to drop oic acid, it goes away, and it will become butanamide. Okay, so let's go ahead and let's do this example below. We'll start at the carbonyl carbon, that's number 1, then number 2. Now we have to go to the longest chain. If we head to the left, that's 3, 4, 5. Going to the right, 3, 4, 5, 6. So we will be going to the right on this. So there's 3, 4, 5, 6. And that means that this group right here, I'm circling in red, is a substituent. And it's actually one of the acceptable common substituents. It's a sec-butyl. So I have a sec-butyl at number 2 and a methyl at number 3. Sec-butyl, remember, we alphabetize by B. So we will have 2 sec-butyl, 3-methyl, and there are 6 carbons. If it were a carboxylic acid, it'd be hexanoic acid. So we got the hexane part. We're dropping oic acid and putting in amide, A-M-I-D-E, hexanamide. So 2 sec-butyl, 3-methyl, hexanamide. Alright, so now we're going to tackle what do you do when the nitrogen is substituted. So that would be secondary or tertiary amides. And what we're going to start out with is very similar to amines, actually. We're going to name these as N-substituted primary amides. So we're going to actually name it as a primary amide, just like we did on the last slide. We're going to indicate there is something actually on that nitrogen by treating that as a substituent. And so what we'll do is we'll name the alkyl substituents on the nitrogen, list them alphabetically with all the other substituents that are on the parent chain. We're going to show they're on the nitrogen by using the letter N, a big N, to indicate their attachment to the nitrogen atom. So this is actually pretty straightforward. They're treated as substituents. And then we'll just name it like usual from there on out. So starting with this one, let's number the chain. Start at the carbonyl carbon. 2, 3, 4, and I'm going to go down towards the chloro because I have more substituents that way. And what I then have, as far as substituents go, is I have a chloro, I have a methyl on the nitrogen, and I have a cyclohexane on. I don't want to forget, too, that I also have a methyl over there on the side chain. So I'm going to have a dimethyl somewhere in there. Alright, let's go ahead and let's name this thing. The chloro will come first, so it's 5-chloro. Then the cyclohexyl, it's on the nitrogen, so N-cyclohexyl. And then I'm going to deal with those methyls. I have one on the nitrogen and one at number 4, so I'm going to go N, 4, and you could go 4, N, dimethyl. And then it is based on 5 carbons, so that'd be pentanoic acid. So pent-an, we're going to drop the oic acid part and put amide. And we are finished. 5-chloro, N-cyclohexyl, N4, dimethyl pentanamide. Okay, let's get into nitriles now. You're going to name a nitrile by determining the number of carbons in the longest chain, and that includes the carbon that is contained in the nitrile. That is counted in the count. And so we're going to start numbering that parent chain beginning at the nitrile carbon. So the nitrile is not considered a substituent. It's actually part of the parent chain. And we'll start at the nitrile carbon. We'll name the parent chain by combining the name of the alkane, so that's just how many carbons are in the chain, plus the word nitrile. And for this one, it is going to be one word. It's going to all be sandwiched in together. Now, since the nitrile, just as a hint here, begins with the letter N, which is not a vowel, what you'll notice when we do the name is we are going to take the alkane name and keep the final E. So make a note that you want to keep that E in the name. Okay, let's go ahead and tackle this one. Here is our nitrile, and I guess we had better figure out where our parent chain will be. So we'll start at the nitrile carbon, come out, up, over, and then longest chain will actually be coming down this way. Alright, now that that is tackled, let's go ahead and number this guy. The nitrile carbon is number 1. Let's do it in black. It's number 1, 2, 3, 4, 5, 6, 7. So it's a heptane. It's going to be a heptane nitrile. Alright, so here we go. We've got chloroisopropyl and methoxy. So we'll have 3-chloro, so isopropyl, so 4-isopropyl, and then we have 5-methoxy, and then I'm going to run out of room, so I'm just going to swing it around here. The next thing, 7 carbons, is heptane. And we're going to keep the E at the end. And then we're going to sandwich right up against it nitrile. So 3-chloral-4-isopropyl 5-methoxy heptane nitrile. And note that we did keep that E right there. Now for the fun part. What do you do when these derivative carbonyls are hanging off of a cycloalkane? You're just going to have to flat out memorize these 5 parents. If it is off of a alkane and it's carboxylic acid, it's cyclohexane, carboxylic acid. If it's an acid chloride, cyclohexane, carbonyl chloride. So let's go ahead and let's just underline the endings. Carboxylic acid, carbonyl chloride. Now if it's an ester, we're going to stay consistent with the first word out front is the group that is attached to the oxygen. Then as a separate word, you're going to have cyclohexane, and the ending you tack on is carboxylate. If it is an amide, cyclohexane, the ending is carboxamide. If it is a nitrile, cyclohexane, and then this one's just weird, carbonitrile. Don't ask me why. Okay, so let's go ahead and let's name this first one. It is based on a cycloheptane, I think. Let's see. 1, 2, 3, 4, 5, 6, 7. Yep, it's a cycloheptane. I see that I have a nitrile group coming off of it, and so it is going to be a cyclohexane carbonitrile parent. Now, as far as the numbering goes, the carbon that has the derivative group attached to it is number 1. And if I go counterclockwise, I have a group at 3. If I go clockwise, I have a group at 3. So let's go into our next branching. Going clockwise, I have those methyls coming right after. I don't hit them till a little further along, going counterclockwise. So I, in this particular instance, will be going in a clockwise direction. So when I do my numbering, there's 1, that'll be 2, 3, 4, 5, 6, and there's 7. Okay, so I think we're about ready to go. We have hydroxy and a bunch of methyl, so hydroxy comes first. 6-hydroxy. Yeah. Let's go ahead and let's erase the L. So 6-hydroxy. And then 3,4,4-trimethyl. And then, just the ending, it's a cycloheptane carbonitrile. We're going to sandwich that right up there. Cycloheptane, see if I can make it fit, carbonitrile. The names are crazy, you're just going to have to memorize them. All right. Now on this particular one, this is going to be a cyclooctane. It's an amide, and so it's going to have the ending carboxamide. The nitrogen is substituted with an ethyl group, so I'm going to treat that as a substituent with an N in front of it. And then I've got that guy hanging off there, which is formal. So I have an ethyl substituent and a formal substituent. So ethyl comes first. It's on the nitrogen, so it gets N. N-ethyl, and numbering 1, 2, the formal's at number 3, so 3-formal, and then just our crazy ending, cyclooctane, and then it is an amide, so we say at the end carboxamide. Okay, my best advice to you is make up some flashcards for these and just memorize them.